This is MSJ Chem. In this video, I'll be looking at activation energy. So let's start with a review of collision theory. So according to collision theory, reactant particles must collide with each other to have a chemical reaction. Colliding particles must satisfy two conditions. The first is that they must collide with kinetic energy equal to or greater than the activation energy for the reaction. The second is that they must collide with the correct orientation. In this video, we'll be focusing on the first point, which is activation energy. So here we have the definition of activation energy. Activation energy is the minimum energy that colliding particles need in order to have a successful collision that results in a chemical reaction. It can be thought of as the energy barrier to a reaction. In this diagram, to get the rock from A to B, this person needs to put in energy to get the rock over this hill. The energy that the person puts in to get the rock to the top of the hill can be thought of as the activation energy for the reaction. Without this addition of energy, the rock cannot get from point A to point B. Another example is the storage of propane gas in a pressurized container. So this propane gas can be safely stored under pressure without undergoing combustion. If the propane gas is ignited by a spark, it undergoes combustion. So propane gas will not undergo combustion unless sufficient energy is supplied, that is, the activation energy. Next, we look at two energy level profiles for an exothermic reaction on the left and an endothermic reaction on the right. The activation energy for the forward reaction is shown by the red arrows on the energy level profiles. So the activation energy is the difference in energy between the reactants and the highest point on the reaction profile. This highest point is known as the transition state. The green arrows show the activation energy for the reverse reaction. So for the reverse reaction, the activation energy is the difference in energy between the products and the highest point on the reaction profile. Next, we look at a Maxwell-Boltzmann distribution curve. On the y-axis, we have number of particles with kinetic energy E, and on the x-axis, we have kinetic energy. The red arrow indicates the activation energy for the reaction. So the area in white is the proportion of particles that have energy less than the activation energy for the reaction. So all these particles in the white area do not have enough energy to react. The area in blue is the proportion of particles that have energy greater than the activation energy. So all the particles in this blue area have sufficient energy to react. So we'll finish the video with some important points about activation energy. The first is that temperature has no effect on the activation energy of a reaction. Slower reactions tend to have higher activation energies, and faster reactions tend to have lower activation energies. And finally, a catalyst provides an alternative reaction pathway with a lower activation energy. This results in an increased rate of reaction. Catalysts are covered in more detail in a later video.